I kindly invite you to present your presentation, which is called Wastewater Recycling. So with your presentation, we come to the second part of our event, which is focused on the recycling. After the state-of-the-art analysis, then we will now focus on the recycling. Jaakko, it's your floor.
Thank you, Kirina Kirkova, and Debrecen. Hello to all. Yes, and thank you for this opportunity to squeeze my 40 years experience in 20 minutes. Let's see how I can do it. And the wastewater recycling background for this knowledge is I'm metallurgic, Master of Science, and I've done like licentiate thesis on glycols, and by that time I learned the chemicals, how they do pollute waters. While working on the steel manufacturers, big companies, and plating companies, for example, and chemical companies, I got involved in this water issue. And of course, money is running the companies, and that was one issue early 80s already, that water should be reused. More after a couple 20 years after that, people start to talk about recycling. So that is to start my presentation. Few facts about water in Europe. The average available renewable freshwater resources per capita among European countries is highly variable, ranging from less than 100 cubic meters per person per year in Malta to about 500,000 cubic meters per person per year in Iceland. So there is a lot of differences in that. A relatively low available renewable freshwater resources is measured in half of European countries. In the past years, the topic of water scarcity and drought has moved to the top of European agenda. In EU report, Water Scarcity and Drought stated that water stress affects 100 million inhabitants, 30% of the population in Europe. Not only the Southern Europe, but also in northern countries such as Belgium, Denmark, Germany, Hungary, and after Brexit, still I have here the country United Kingdom. Just to mention here about the Germany, I learned water recycling and wastewater treatment at Duisburg in the steel manufacturing company, and they took the water from the river, and it was much cleaner than we let it out back to the river from the steel factory site. It was very interesting time to learn how Germans did it. Today, in the EU level, there are several efforts that are focused to save our water resources. So now it comes up to the state level. We have Industrial Emission Directive, and I have been working with the ECHA, European Chemical Agency, with these directive issues. 21 PREF documents, among other legislation, to reduce pollutants. Now in Finland, we have started to collect for plating industry the group of experts to do the next PREF document. So that is just as we started to collect people on September, and I'm one of the volunteers, let's say. There are the chemical bottles. Meaning of those is that while I was in the German company, chemical company called Henkel, I learned as being a part of the core team for several years, the raw materials that are used in households, in industrial chemicals. And again, I faced the problems that how wastewater plants can treat all those various raw materials. How can they clean it? Not only nitrogen or phosphate we are talking about. We are talking about very small amounts of hydrotrophs, tensides, complexing agents, which are really important to know when doing recycling. The water services as the framework of circular economy is quite large. There in the red area is today's topic. There are municipal community factors, water treatment after water field, drinking water distribution, wastewater treatment, after that sludge treatment, nutrient recovery and recycling. And to the Mr. who had the presentation just before me, he was asking about the regulations. So in Finland we have hot topic on these sludge treatment regulations. So that is different regulations in each EU country, let's say. I'm not a expert on that, but I've been sitting on around the tables that they have the tight restrictions to the sludge. From circular economy, we are going to reuse water or not. It depends on the cases. Intake or recycled water quality. I start from the quality issue. Freshwater quality influences strongly when selecting the wastewater process, as well recycling possibilities. In Finland, we have the highest top quality fresh water, was stated by the United Nations. I think it was 5 or 4 years ago. I've been working in Norway, and in Norway the fresh water from the rivers, from the mountains, that is as like demineralized water or distilled water. It is very hard to work in industrial level or in tubing, because there is no calcium, magnesium ions that makes a protective layer to the tubings. Just to mention the high mountains that they collect the waters there, and pumping problems. Well, in some cases, softened riverbank filtered water can be used. That's still in Finland in several cases. Generally, it's known that high total hardness is common in EU or too high boron, as in parts in Italy. I faced that problem a couple of years ago in the few companies I was consulting. I don't know the situation in Czech, but I think you have this high hardness as well over there. After the wastewater, of course, and the chlorides corrodes iron and steel materials as organics harm filters. And one fact is that before Finland joined European Union, there was a chloride limit in our drinking water, 100 milligrams per liter. That was pretty good level, because in the European Union, it jumped up to 300 milligrams per liter. And guess what? 300 milligrams chlorides, that corrodes quite heavily the wastewater plant tubings and other goods in this our water maintenance system. While after the wastewater treatment plant, some impurities are still left in the water that would be or want to be reused, recycled. Quality must be carefully characterized, including exact limits. When using recycled water only partly to the system, user needs to know the cyclode concentration to avoid too high amounts of harmful components. Diagnostic tools, sensors, and software applications are nowadays used to manage concentration to appropriate levels. But plus, we should not forget the traditional laboratory work in these analyses. As in the previous presentation, the chemical wastewater treatment lines, those are what we are facing in Europe, and in recirculation purposes, the traditional direct precipitation is not enough. It makes more difficult this issue of wastewater treatment, because when we have a direct precipitation, that is typically the time that takes to clean the water is 3.5 hours. Then we add their precipitation and pretreatments. It triples the time. Different pre-precipitation stages. When they are effect processes, that is 8.5 hours. If we have post-precipitation or tertiary processes after the normal chemical wastewater section, here we go up to the 13 hours. So it is a time issue as well. So the wastewater treatment lines needs more processes units to purify wastewater down to accepted level. And I have followed during my career time that in the 80s it was very, very simple, these wastewater treatments. Today we have these tertiary treatments that is more or less, we find it all over today. And as we go to next slide, I want to focus on few requirements to control recycling. Regular analyses, metering unit checks, plant inspections, corrosion measurements, information of responsible personnel, and feedback from all the information collected from the wastewater plant is very important. Today we use monitoring software, proper software, automatic control for water data, and good maintenance of probes helps us to do that work. Interpretation of the treatment results, we need consults maybe outside from the wastewater plant. Typically in Finland, the size of the city inhabitants, let's say 25 to 40,000 people, they have a wastewater treatment plant which has less than 10 people working in there. So they need consultants and other experts to run the plant. There is so much today to be known exact, let's say, that is not science, but how to run the lines. The laboratory studies and interpretation analysis of solids, surface analysis, etc. What do they tell to the workers how the process is running? Treatment monitoring and reporting to official is often required. And each wastewater plant has their own limits that they have to obey. Also, I have faced many times this microbiological growth. It makes always costs. And the important role of biocides. I picked up a few biocides here, and in my experience, sooner or later the biocides are needed. We have to follow the local regulations and use accepted chemicals when needed. You know much better this biocide issue as micropollutants, but here are a few facts that historically against fungi in plant operation, Dasomet was the first with clause will not pose unreasonable risks or adverse effects to humans or the environment. And also there is the other THPS chemical, and from the year 1995, Environmental Protection Agency of the US ranked this with zero toxic chemical and was awarded with US Global Green Chemical Prize. Well, let's go back to the 80s. We pumped into the wastewaters huge amounts of polluting chemicals. And in next slides, I want to go to point out that these chemical treatments, officials have tackled it by piece, and in drinking water treatment, we have certifications. They are coming from the United States. This is one of the, I want to point out, this NSF 60, drinking water treatment chemicals. This standard contains health effect requirements for drinking water treatment chemicals that are directly added to the water and are intended to present in the finished water. This issue came up when I was in the project that in Singapore, they are using cleaned wastewater. They are recycling wastewater into the drinking water. 30% of the drinking water in Singapore is produced from the wastewater. That was quite surprising 10 years ago when I was in that project. And this NSF standard was very important, kind of a level that we had to stick in. That standard connections covers even to drinking water plant constructions in more details as materials, coatings, etc. at site. So the standards are globally and accepted the public health standards. Then recycled water is aimed as tap water regulation that should be followed carefully, and here is the link to organization sites. This latest version of this NSF 60 standard will be in effect 1st January 2022. And here are listed few typical chemicals that are needed in drinking water treatments, and they are coagulants, flocculants, disinfectants, and oxidation chemicals, pH adjustment, softening, precipitation, specialty chemicals. While I was working in the chemical industries, raw materials, there are available a lot of these water treatment chemicals, and should be taken very good care that where the wastewater plants they buy those, there are impurities. There might be impurities in the products, and when you are aiming to recycle the water, you have to think carefully that what is the target on recycling the water. Does it go to drinking water? Does it go only to inside the industry? So take care that you buy the right quality water treatment chemicals. Advanced wastewater management to reuse water. There are few things I would like to highlight here. Those impurities could be coming from the intake water that disturbs normal cleaning process critically, or they comes from the wastewater. Is it from municipal side? Is it from industry side? Doesn't matter, but there comes disturbing units, that's for sure. In industry, it is easier to remove the source of pollution or isolate the disturbing unit. In in-house recycle cases that remove undesired components before entering into the main process, that is good management. And use a correct policy instrument, follow the environmental permits. That helps to keep the process running on the right quality level. quality targets, cycle of concentration, and everyone who is doing on water treatment business, they know the cooling tower's basic technology, that when the feed water is added partly to the system, the concentration of the harmful ions, they typically go higher and higher. When managing the technology, targeted technologies, we have to think the source of separating systems. There are a lot of technical processes to select from. One is to control on a pre-treatment level, wastewater treatment plants, using enzymes, de-emulgators, filtrations, and dozens more technologies are available. For example, there are oils, different oils coming into the wastewater plants. Those stuck the filtration, mechanical filtration stage. So one pre-treatment, then here could be the emulgator that breaks down the oil films. And frequent environmental impact assessment should be done. There is all legislations focused, which are collected the information to the environmental permits, and we have to inform the officials, not every year, but quite typically in 4 or 5 years, and rename the levels of the impurities and pollutants. And of course, when improving the processes, the cost and risk assessment should be followed by proper plant maintenance. Nutrient recycling is today a very hot topic, and risk that should be followed, risk management in sludge treatments. And there are several projects running in Finland of different sludge treatments. Are those done at site, or should be the sludge treatment collected in 2 or 3 places around Finland? So very interesting issues. Now we go to advanced wastewater technologies to reuse water. When I was starting this recycling of water, that was quite easy. The pollutant levels were quite high, accepted, and some pollutants were just allowed to put on the wastewater. Today, the strict legislation makes it that is a must to do, for example, tertiary treatment at wastewater plant. Chemical treatments, not only the classic ones, but new chemicals processes are available. Oxidation with all its different oxidation forms, not only the wet oxidation, but then we go, for example, case Sansox. There is a tubing that is water and gases are mixed very, very well together, and it oxidizes the impurities, for example, that is used in the caviar farm plant in Finland. And that makes the water possible to recycle. Ozone could be used with combinations also in pretreatment. UV light, different wavelengths. I have been with in the projects where we studied different wavelengths, and it gave very surprisingly different results in the cleaning wastewater. And ultrasound, we should not forget that. New steps have been taken in sorbents, granular active carbon, zeolite, silica-based compounds. Those are the classical ones, but there are now different new approaches on the materials. Filtrations are in tertiary step, nanofiltrations and reverse osmosis. Those are definitely has to be used when doing drinking water quality. And the next slide has later I come to this pulsed corona discharge, which is new technology in our markets. And the technologies are really taking good steps on sludge management. And there are projects, as I have been telling, is on the nutrient recovery, and also an interesting issue is hazardous waste separations and treatment technologies. And there a case is that on the markets we have a direct heavy metal precipitation with a sweeping method over pH. It takes 100 times more effective heavy metals to precipitate than the hydroxide precipitation method. That is used in big water uses like in mining industry, but could be used as well in recycling in municipal site as well. Few technical solutions to pre or tertiary stages in the 2020s is there. I told about the novel fiber materials and solutions for extraction of metals, radioactive and
Jaakko, I'm very sorry, as a moderator, I have to remind you about time.
Okay.
We have 5 minutes, so like 5 minutes time, please.
Thank you. Thank you. So there's a selective membranes. We have in recycling tap plating line that removes nickel ions and they recycle water. Electrocoagulation, attached with patented chemical path configuration. There's a pulse charge discharge, and here is that flow chart, how we take disinfection medicine residues away and special harm for wastewater streams. Now we hear today more about these drugs on tap and the innovative approaches there are all the time going on. But first slide here is I want to introduce the Finnish Water Forum. That is a platform over 130 members that includes research and educational institute, associations, companies, and 5 ministries. We are a non-profit organization, and our mission is to find solutions to global water and climate challenges through Finnish know-how and technology together with local and international actors. We are offering partners in the field of wastewater recycling technologies and management issues on national, international levels. We are offering knowledge partners to find solutions to water-related challenges at site. And we provide project expertise through Finnish know-how and technology together with local and international actors. So we are one-stop shop to water-related challenges. And when you are looking at a partner, you can contact me so I can start discussing who could be the partner for you. Thank you for your attendances. And
Jaakko, thank you very much for your presentation. You have presented a very detailed picture about technologies and the advances. But you have mentioned more times the requirements to control recycling. And you are project manager for the Finnish Water Forum, which is really a large network of institutions.
yes.
Could you give us the information, what is in your view, in your perspective, the main gap in the regulatory environment? What's missing in terms of requirements and regulatory pressure to incentivize more recycling, more water recycling? What would help?
Well, in Finland we have enough water. Yes, that is an issue. Then I have been traveling abroad in there's a scarcity. That is, let's say, I'm not an expert to answer to that question. I've been traveling in Africa. I've been traveling in Russia. I know the quality of water they are drinking there, and that is awful. But I don't have the answer to your question. I'm sorry.
Yeah, maybe the answer to what might incentivize it's the water scarcity as to your experience, not the legislative framework, but just the water scarcity. When it comes, then the incentives come.
I was working in a chemical company called Finnish chemical company called Kemira, and I was running over 10 million euro project with 36 doctors in my team. I was surrounded by the experts, and we were working on desalination plants where they are making good, fresh drinking water. And then there came the Arab Spring, the war in this area, and none of the desalination plant was demolished. No rockets was shooting to the drinking plants, desalination plants. So those guys did know that this is something so important issue, the water, that we don't shoot those down.
Destroy the infrastructure.
Destroy.
Yeah. Thank you very much for your presentation.
You are welcome.
And I